Hello friends, and welcome back for the last session of today, in which we'll be finishing off this neuroanatomy. Till now we are done with the association fibers and commissure fibers, but we'll be needing these some more discussion about this commissure fiber so that we can talk about the lateral ventricle and also the third ventricle. So I'll begin with the commissure fiber again. I'll continue with the commissure fiber. Now till now we see two sections. We saw a sagittal section in which we saw different part of corpus callosum and how other commissure fibers are arranged there. If I take a section, if I take a transverse section, then we saw what are the forceps major and minor fibers we have there. And now if we take a coronal section, now the third section that we're going to take is the coronal section, and this coronal section will also help us understand the walls of the ventricle. So let us take a coronal section. So let's take a coronal section, and in the coronal section let us understand how the things will look like. So guys, if I take a coronal section, first of all, how corpus callosum will look like. Corpus callosum will be like this, going from one cerebral hemisphere to another cerebral hemisphere. This is corpus callosum. Let's say this is cerebral hemisphere here. As I said, it's a coronal section. You're looking at the corpus callosum. This is corpus callosum. These are the two cerebral hemisphere. If I draw it like this, that is corpus callosum. From the undersurface of corpus callosum, we have this septum pellucidum, which is attached to these fornix. This is called as septum pellucidum. I'm just writing SP here. SP stands for septum pellucidum. Septum pellucidum. That is thalamus. Let's say these are the thalamus here. Just writing TH, that is thalamus. That is body of caudate nucleus. And between the thalamus and body of caudate nucleus, we will see thalamostriate vein and stria terminalis. There is thalamostriate vein and stria terminalis. Thalamostriate vein and stria terminalis. I also need to draw the choroid plexus present here, the choroid plexus, which is seen like this. This is the choroid plexus. That is the choroid plexus. So guys, this is lateral ventricle here. I mean, I'm just drawing it on this side here. This is lateral ventricle. Lateral ventricle is having the medial wall. This is medial wall of lateral ventricle. This whole thing is the floor of lateral ventricle, and this is roof of lateral ventricle. So this is lateral ventricle you're looking at, and this is third ventricle we have here. So what you can see in the lateral ventricle, that the floor of lateral ventricle is made up of all these things. There is no lateral wall of lateral ventricle. We have this whole thing is the floor of lateral ventricle, body of caudate nucleus, stria terminalis, thalamostriate vein, choroid plexus, and even this fornix. The fornix. all these structures are forming the floor for, these are of floor of lateral ventricle. These are all forming the floor of lateral ventricle, body of lateral ventricle, that is floor of lateral ventricle. Corpus callosum, corpus callosum here is forming the roof. Corpus callosum is forming the roof, and septum pellucidum, as you can see, is forming the medial wall. That is the boundaries of body of lateral ventricle. So floor, as we can see, the floor is by the all these structures: body of caudate nucleus, stria terminalis, thalamus striate vein, thalamus. Make sure you add thalamus also to this. Thalamus, choroid plexus, and even the fornix. So all these, the lower part of the fornix, so all these are forming the floor of lateral ventricle. The roof is by corpus callosum, and the medial wall of the lateral ventricle is by septum pellucidum. So there is floor, this is roof, and that is medial wall. That is about the lateral ventricle. Now third ventricle, if you see, now what are the roof, medial wall, and the floor of the third ventricle? Third ventricle can be better understood if we look at the sagittal section of the cerebral hemisphere. And one thing about the third ventricle, the question usually in the third ventricle is about the floor of third ventricle. Guys, when you look at the interpeduncular fossa, now look at me, if this is a brainstem here, this is a brainstem you are looking at, and these are the two cerebral peduncle. We have the two cerebral peduncle or the crus cerebri. What is there in between? That is interpeduncular fossa. If you see from that side, if this is my brainstem here and you guys are looking at it, so from your side it is interpeduncular fossa. But if I see it from inside the brain, if I see it from this side, then the same structures which are present in the floor of the interpeduncular fossa are forming the floor of third ventricle. So when you see it from the front, that becomes interpeduncular fossa. When you see it from inside, the same structures are forming the floor for interpeduncular, floor for third ventricle. So for third ventricle, so what I am saying, for third ventricle, these are the medial wall, roof, floor for fourth, this one lateral ventricle. So this is about the lateral ventricle. Whereas for third ventricle, what we can already see from this, from the third ventricle, that the lateral wall of third ventricle is by thalamus and the lower part by hypothalamus. So thalamus and hypothalamus, if I draw hypothalamus here, let's say thalamus and hypothalamus, they will make the lateral wall of third ventricle. But the main thing is about the floor. The questions are about the floor. So let me take this. If this is the corpus callosum, if you remember what was the gland present below the corpus callosum, splenium of corpus callosum, the gland was the pineal gland. So guys, if this is pineal gland here, and we know we have two laminas of the pineal gland. Pineal gland, and what commissure is this? The inferior one. This is called as what commissure? That is posterior commissure. If you remember from commissural fiber, this is posterior commissure. Pineal gland and posterior commissure, which I am denoting there. This is the rostrum of corpus callosum. Below this we have lamina terminalis. Below lamina terminalis, you will find the optic chiasma, followed by the infundibulum of pituitary gland, followed by mammillary body. Then we have posterior perforating substance, and this is aqueduct, which is leading into the fourth ventricle. See, let me write it down and then I'll explain to this. This is called as lamina terminalis. What commissure was there below this thing? There was the anterior commissure. If you remember, below the rostrum of corpus callosum there was anterior commissure. And these structure, I'll give you the number. This is 1, 2, 3 and 4. This is third ventricle. See, anterior wall of third ventricle is by these structures. I mean, this is anterior wall of third ventricle, that is by anterior commissure and lamina terminalis. It is by anterior commissure and lamina terminalis. Posterior wall are by these three structures. This is the posterior wall. Posterior wall is by pineal gland. In the inferior lamina of the pineal gland we have posterior commissure, and below this we can see the aqueduct. So all these things are forming the posterior wall of third ventricle. Very important, floor. The questions are usually on the floor. Floor is important. Now floor, let me compare the floor to the interpeduncular fossa. If you remember interpeduncular fossa, let me just quickly go through that interpeduncular fossa, guys. This was interpeduncular fossa, right? And there was infundibulum there, this was mammillary body and posterior perforating substance. Now there was third nerve as well. Now forget about the third nerve, and only consider these things. Only consider these things which are in here. So this middle part of the interpeduncular fossa, I mean this midline portion of the interpeduncular fossa is forming the floor for third ventricle. When you see it from the front, it is interpeduncular fossa. When you see it from that side, it is the floor of third ventricle, except third nerve. That is more important to remember, except third nerve. So floor is by, if you go in that sequence, the first thing is optic chiasma, which in this diagram is represented by 1, that is optic chiasma. Next thing in this picture, if you go, that is second thing is infundibulum, which is 2 here. Next thing, the section is going through the mammillary bodies, which is 3 over there, and then what substance? That is posterior perforating substance. Posterior perforating substance, which is marked as 4. So please note that the floor of the third ventricle is formed by the structures of interpeduncular fossa except the nerve, except third nerve. So optic chiasma, infundibulum, mammillary body, posterior perforating substance, they are all forming the floor of third ventricle except third nerve, which is present in the interpeduncular fossa but not in the floor of third ventricle. So this is anterior wall, that is floor, that is the posterior wall. Lateral wall we can see from this image, lateral wall is by the thalamus and hypothalamus. Just to complete this thing, lateral wall is by thalamus and hypothalamus, and the roof is just by the pia mater. We can see the choroid plexus, this is the choroid plexus which is extending here. So roof is just by the pia mater stretching between the two thalamus. So roof is only pia mater stretching between two thalamus and nothing much. So lateral wall is by thalamus and hypothalamus, roof is by pia mater. Floor is the most important thing for the PG point of view, from the examination point of view, that optic chiasma, infundibulum, mammillary body and posterior perforating substance except third nerve, which is also in the interpeduncular fossa, all are forming the floor. Posterior wall is by pineal gland, posterior commissure and the aqueduct. This is posterior wall, and the floor is by all these, that is anterior wall is by, lamina terminalis and anterior commissure. So this is something about the lateral ventricle and third ventricle, the important things about lateral and third ventricle. So we are done with the association fibers, we are done with the commissural fibers. Now let's come to the last one, that is the projection fibers. Projection fibers, that is internal capsule and corona radiata. So let us finally come to the projection fibers. Now first of all, internal capsule and coronary radiata, basically they are both same thing only. Internal capsule are more compact, once they spread around they are called as the coronary radiata. And what is the junction guys? Upper border of corpus callosum is the junction. I mean if this is corpus callosum here, till the upper border of corpus callosum we call it internal capsule. Till here this all is internal capsule, this compact bundle is called as internal capsule. And once it reaches the upper border of corpus callosum, now it will spread everywhere in the cortex. Now we start calling it corona radiata. So this is all corona radiata here, this is the internal capsule. As I said, the junction is the upper border of corpus callosum. First let us see what are the parts of internal capsule. The parts of internal capsule are, we have anterior limb, genu, posterior limb. See, we have a nucleus here that is called as lentiform nucleus. On the lateral side there is a nucleus that is called as lentiform nucleus. So this nucleus here is referred as the lentiform nucleus. Lens shaped nucleus called as lentiform. Here we have is the head of caudate nucleus. Head of caudate nucleus, and then we have thalamus. The thalamus. So the parts of internal capsule, this is anterior limb here, that is genu, this is posterior limb, this is retrolentiform part, and the one portion which we can't see, we just drawing it for the sake of reference, that is called as sublentiform part. So I'm just drawing it for the reference only. Let's say this is sublentiform part, somewhere below the lentiform nucleus. I said the part AL is for the anterior limb, G is for genu, PL for posterior limb, R and S. R is for sublentiform part behind the lentiform. R is for retrolentiform part behind the lentiform nucleus, and S is for sublentiform part. S is for sublentiform part which is present below the lentiform nucleus. So these are the parts of internal capsule. As you can see, the anterior limb is present between the caudate nucleus and lentiform, the posterior limb is present between lentiform and thalamus, retrolentiform part is behind the lentiform nucleus, and sublentiform is just for the reference here, although it is present deep to the lentiform nucleus. Is deep to the lentiform nucleus, which we can't see it here, we are just drawing it for the sake of reference. The question is, what are the tracts which are going through the internal capsule? The tracts which are going through internal capsule are ascending and descending tract. So if I say what are the ascending tracts which need to go through internal capsule, now guys, all the ascending tracts which are going through the internal capsule, they are the thalamic radiations. Everything going toward the cortex first comes to the thalamus and then it radiates in different direction. So if this is the internal capsule here, this is the thalamus here, sorry. So from the thalamus we have these thalamic radiations going all over in the cortex. This is superior thalamic radiation, anterior thalamic radiation, inferior thalamic radiation, and posterior thalamic radiation. So ascending tracts which will go through the internal capsule are the thalamic radiation, superior thalamic, inferior thalamic, anterior thalamic, posterior thalamic radiation, out of which the posterior thalamic radiations which are actually coming from the lateral geniculate body are called as optic radiations. Posterior thalamic radiations are called as optic radiation, whereas inferior thalamic radiations are called as auditory radiations or acoustic radiations. Inferior thalamic radiations are called as acoustic radiations or auditory radiations. So first let's see how ascending tracts are arranged inside the internal capsule, and then we'll come to the descending one. So once again we'll go with the same schematic picture here. This is the internal capsule with the anterior limb, genu, posterior limb, retrolentiform part and sublentiform part. You already know what this schematic diagram represents. Anterior thalamic radiation will go from the anterior limb only. Anterior thalamic radiation goes from the anterior limb. Superior thalamic radiation, they will pass from the genu as well as from the posterior limb. Superior thalamic radiation, they pass from the genu as well as from the posterior limb. Retrolentiform part and sublentiform part. See, it's very easy to remember, guys. Retrolentiform part, that means behind. And what is the most important cortex we have behind? That is the visual cortex. So visual radiation or optic radiation will go from the retrolentiform part because they have to go posteriorly. So they will go from the most posterior part of the internal capsule. And sublentiform part will give passage to those fibers which has to go down into the temporal lobe. Now temporal lobe is below, and what is the most important area in the temporal lobe? That is auditory cortex. So the fibers for the auditory region has to go from the lower part of the internal capsule, which is sublentiform part. So optic radiations, as I told you, optic radiations are the one which are coming from lateral geniculate body. Just to tell more about this, from the lateral geniculate body, these are the optic radiations, and from medial geniculate body are the auditory radiation. So optic radiations are going from the retrolentiform part, and acoustic radiation or auditory radiations are going from the sublentiform part. So this is about the ascending tracts, how ascending tracts are arranged inside the internal capsule. Anterior thalamic radiation from the anterior part, superior from the genu and posterior, optic radiation from the retrolentiform part and auditory from the sublentiform part. What about descending tracts? Let's see how descending tracts are arranged inside the internal capsule. So first let's make a list of the descending tracts which need to go through the internal capsule. Coming from the cortex. Now obviously from the cortex we have corticospinal tract. So we need to place this corticospinal tract somewhere in the internal capsule. We also have corticonuclear or called as corticobulbar tract, that is upper motor neuron for the cranial nerves, corticonuclear coming from premotor area. And if you remember, we said corticospinal tract, there is a copy of corticospinal tract which goes to the cerebellum called as corticopontocerebellar. Corticopontocerebellar tract. Corticopontocerebellar is a vague term. We are saying corticopontocerebellar. It can be from any part of the cortex. It can be frontopontocerebellar, paritopontocerebellar, temporopontocerebellar. So we have different types of corticopontocerebellar tracts, like coming from the 4 different lobes: fronto, occipito, parieto and temporo pontocerebellar. Frontopontocerebellar, occipitopontocerebellar, paritopontocerebellar and temporopontocerebellar. So we need to place all these tracts and see which part of the internal capsule they will go from. Once again, the anterior limb, genu, posterior limb, retrolentiform part and sublentiform part. Frontopontocerebellar. Now let me use some color code to denote them. Frontopontocerebellar. I am using this red for the frontopontocerebellar. This is going through the anterior limb, from the genu, and even from the posterior limb. It is most extensive. So frontopontocerebellar, as you can see, if I am going in a color code, that frontopontocerebellar is from the anterior limb, genu and the posterior limb. Occipitoponto and paritoponto, both these. Occipitoponto and paritoponto, the one with the blue here, is going from the retrolentiform part. Is going from the retrolentiform part. And temporopontocerebellar is going from the sublentiform part. Is going from the sublentiform part. So frontopontocerebellar from anterior limb, genu and posterior limb, occipitoponto and paritoponto from the retrolentiform part, and temporoponto, as we know, anything going to the temporal lobe or coming from the temporal lobe, it has to go from the lower part of the internal capsule, and that is sublentiform part. Coming to the two major here, that is corticospinal and corticonuclear. Corticospinal and corticonuclear. Corticonuclear tract goes from the genu. Corticonuclear will go from the genu. That is, corticonuclear tract will go from the genu, and corticospinal from the anterior 2/3 of the posterior limb, precisely corticospinal tract will go from the anterior 2/3 of posterior limb. Make sure you write this, from the anterior 2/3 of posterior limb. It goes from the anterior 2/3 of the posterior limb, and the somatotopic arrangement of the body in the internal capsule is like this. This is how body is represented. I mean, the fibers for the head and neck, cranial nerve nuclei, fibers for the cranial nerve nuclei are from the genu, so corticonuclear. For the upper limb are going from here, from the trunk they are going from the middle part, and the posterior part from the lower limb. So the body in the internal capsule is represented like this. So this is all about the internal capsule or projection fibers. The fibers, how all ascending and descending tract, they are compact and they are present inside the internal capsule. So lastly, let's talk about the blood supply of the internal capsule and also the different branches of the major artery like vertebral, internal carotid and basilar, and that will conclude the neuro part for us. Okay. So let's first start with the blood supply of internal capsule. Now I would ask you guys to make internal capsule on one side of the page, so that on other side we can draw circle of Willis and we can fetch the branches to internal capsule. So please make sure you do it exactly the way I am doing it here, and also label it this way only. So this is internal capsule once again. I'm going with the same thing. Anterior limb, genu, posterior limb, retrolentiform part and sublentiform part. So draw the internal capsule on the left side of your page, so that on this side we can draw the circle of Willis and we can see what branches are coming and supplying the internal capsule. And do not label anything between the circle of Willis and internal capsule. So there we go, guys. If this is the vertebral artery, the vertebral artery together fuse to form this basilar, and the basilar artery divides, as we know, into the posterior cerebral artery. So this is the posterior circulation first. So we have, make sure you label everything on the right side. So this is the vertebral artery. That is basilar artery, and this is posterior cerebral artery, that is division of basilar artery, that is posterior circulation, vertebral, basilar and posterior cerebral. Anterior circulation is all about circle of Willis, and circle of Willis, that is by internal carotid artery first. So we have this internal carotid artery, let's say. The continuation of the internal carotid artery, which artery is considered as the continuation of internal carotid? That is middle cerebral. This is internal carotid artery. This one is middle cerebral artery. The one which is regarded as the continuation of internal carotid is middle cerebral. The internal carotid is connected behind by these posterior communicating arteries. This is posterior communicating. That is anterior cerebral artery, and both the anterior cerebral arteries are connected to each other by anterior communicating. This is anterior cerebral artery, and this is anterior communicating artery. This here is posterior communicating artery, and there is one more direct branch of the internal carotid artery which we need to see here, and that is anterior choroidal. This is called as anterior choroidal artery. Anterior choroidal artery. Posterior choroidal is a branch of posterior cerebral. We are looking at only anterior choroidal artery. So these are the major branches that we have from the internal carotid, that is anterior circulation, circle of Willis, and that is posterior circulation. Now let's see what are the branches from this circle of Willis will supply the internal capsule and precisely which part. Anterior cerebral artery. Now look at this. Anterior cerebral artery proximal to the anterior communicating gives off a branch. Proximal to anterior communicating gives off a branch which comes and supply anterior limb, which comes and supplies the anterior limb and the genu. This artery is coming back, and it is coming back from the, it is going through the anterior perforating substance. I hope you remember where was the anterior perforating substance, between the two stria of the olfactory tract, and this artery is called as recurrent artery of Hubner. That is recurrent artery of Hubner. This is referred as recurrent artery of Hubner. It's a branch of the posterior anterior cerebral artery. We call it recurrent artery of Hubner. Anterior cerebral artery proximal to anterior communicating, passing through anterior perforating substance. Now middle cerebral artery gives off branch to supply the posterior limb. It also supplies the genu. There are many branches coming from the middle cerebral supplying the posterior limb, but this branch which I want to specially talk about, this is called as the Charcot's artery. This is called as Charcot's artery. It's a branch of this middle cerebral artery, the Charcot's artery, and the Charcot's artery is also referred as the lenticulostriate branch. Please note that. Another name for the Charcot's artery is also called as lenticulostriate branch or lenticulostriate artery, and this lenticulostriate artery is also referred as, or this Charcot artery is also referred as, artery of cerebral hemorrhage. It is most commonly involved in the intracerebral hemorrhage. So Charcot's artery is also referred as artery of cerebral hemorrhage, artery of cerebral hemorrhage. Anterior choroidal artery. The anterior choroidal artery, it will supply the posterior part of posterior limb and sublentiform part. This is anterior choroidal artery. Anterior choroidal artery supplies posterior part of posterior limb and sublentiform part. Whereas branch from the posterior cerebral artery, now look at this, branch from the posterior cerebral artery supplies sublentiform part, it supplies retrolentiform part, and it also gives collateral to the posterior limb. It also supplies a part of posterior limb. So this is from posterior cerebral artery. The branch from the posterior cerebral artery, branches from posterior cerebral artery, they will supply sublentiform part, retrolentiform part, and posterior part of the posterior limb. Now they asked this question once, that which of the following artery is not supplying the posterior limb. Now which of the following artery is not supplying posterior limb? Now what artery you can see supplying posterior limb? Charcot's artery is supplying posterior limb, anterior choroidal is supplying the posterior limb, and even posterior cerebral is supplying the posterior limb. So please guys, just write down all the three branches supplying the posterior limb at one place. That posterior limb is supplied by Charcot's, anterior choroidal, as well as posterior cerebral artery. Posterior limb is supplied by Charcot's, anterior choroidal, and posterior cerebral artery. And please also note that anterior choroidal artery, we said what is Charcot's artery? Charcot's artery is the artery of cerebral hemorrhage. Also note that anterior choroidal artery is the artery of cerebral thrombosis. Anterior choroidal artery is also called as artery of cerebral thrombosis. It is also referred as artery of cerebral thrombosis. Artery of cerebral thrombosis. Why we call it artery of cerebral thrombosis? It's a very long artery with a narrow lumen, very narrow lumen. So it can easily be occluded by the thrombus. It can easily occluded by the thrombus, so we call it artery of cerebral thrombosis. Finally, about the branches of, you can see most of the branches of internal carotid artery here only. But let me tell you something more about the branches of internal carotid. Branches of ICA. Internal carotid artery, guys, see, there are two parts of internal carotid artery which we need to look at here. One, if this is cavernous sinus, if you remember, we said internal carotid artery will go through the cavernous sinus. So internal carotid artery go through the cavernous sinus, makes carotid siphon and come above. So internal carotid artery, which you can see, it is going through the cavernous sinus and then can it come above and form the circle of Willis and contribute to circle of Willis. So there are two parts of this internal carotid artery in this region here. One, this is one, and let's say this is two. One is called as intracavernal part. One is the intracavernal part of internal carotid artery, which gives off meningeal branches to the walls of cavernous sinus. Plus, it also gives off inferior hypophyseal artery to the pituitary gland. So, intracavernal part, when the internal carotid artery is running inside the cavernous sinus, it gives off meningeal branches to the walls of cavernous sinus, and it also gives off the inferior hypophyseal artery. Once it comes outside the cavernous sinus, that is second part, that is extra cavernal part or cerebral part. Extra cavernal part of internal carotid artery. First it gives off the superior hypophyseal artery. First it gives off the superior hypophyseal artery. Then it gives off ophthalmic artery, and rest of the branches we already discussed. This is 1, this is 2. What are other direct branches of internal carotid? Anterior cerebral 3, middle cerebral 4, anterior choroidal 5, and posterior communicating 6. Let me highlight them once again. This is 1, 2, 3 anterior cerebral, make sure you write it. 4 is middle cerebral, 5 anterior choroidal, and 6 posterior communicating. These are the branches from the extra cavernal part of internal carotid artery. Superior hypophyseal, ophthalmic, and these branches which we saw in the circle of Willis: anterior cerebral, middle cerebral, anterior choroidal, posterior communicating. What about the branches of basilar artery and vertebral artery? Branches of basilar and vertebral artery. The branches of vertebral artery, as we know, the vertebral artery is running on the medulla. So branches of vertebral artery are, we have anterior spinal artery. It gives off posterior spinal artery, supplies the medulla oblongata as well as the spinal cord. It gives off medullary branches as it runs on the medulla. Also gives off this very important branch called as spica, posterior inferior cerebellar artery, and it also gives off meningeal branches. It supplies the dura mater of the posterior cranial fossa, so it gives off meningeal artery as well. The one which we need to focus here is the pica, posterior inferior cerebellar artery. It's the artery which is involved in the lateral medullary syndrome, and this is the artery which supplies the lateral part of medulla oblongata, pica. Whereas branches of basilar artery, the branches of basilar artery is running on pons, so it will give off pontine branches. It divides into two terminal branches that are posterior cerebral artery It also gives off two branches which supplies the cerebellum. See, one branch of the cerebellum is coming from here, that is in posterior inferior cerebellar. It will give off superior cerebellar artery, and it also gives off ICA, that is anterior inferior cerebellar artery, anterior inferior cerebellar artery. And labyrinthine artery. Now remember one thing, that superior cerebellar artery, anterior inferior cerebellar artery, and posterior inferior cerebellar artery. These are the three arteries of cerebellum. So cerebellum is supplied by one branch from the vertebral and two branches from the basilar artery. And if guys, the question is asked on the labyrinthine artery, that labyrinthine artery is a branch of, and if you have option of basilar artery and anterior inferior cerebellar artery to choose from, so please go with anterior inferior cerebellar artery, because in most of the cases it's not the direct branch, it is usually the branch of the anterior inferior cerebellar only. Labyrinthine artery, mostly it is the branch of anterior inferior cerebellar artery and not the direct branch of basilar. Sometime it is, so I have written it here, but most of the cases it is the branch of anterior inferior cerebellar artery. Looking at what out of the cerebral arteries, the anterior cerebral, middle cerebral and posterior cerebral artery, which artery is the dominant artery of which surface? So guys, when you look at the superolateral surface here, on the superolateral surface the dominant artery is middle cerebral. The majority of the part of the superolateral surface this is by middle cerebral artery. Only a thin strip along the upper border is by the anterior cerebral and occipital lobe and occipital cortex is all about the posterior cerebral artery. Whereas on the medial surface the story is slightly different. On the medial surface the dominant artery is anterior cerebral. Anterior cerebral is the dominant artery on the medial surface. The second dominant artery which you can see here is the posterior cerebral, mainly to the temporal lobes on its undersurface and occipital cortex. And the small part that is the temporal poles, that is still by the middle cerebral artery. This is how the arterial division is to be seen on the superolateral surface and medial surface of the brain. Superolateral surface and medial surface of the brain. And the very last thing, that is about the 4 types of hemorrhages and the blood vessel involved in them. One is extradural hemorrhage, subdural hemorrhage, subarachnoid hemorrhage, and intracerebral hemorrhage. That what blood vessels are involved in these cases, guys. Extradural hemorrhage, the blood vessel which is involved usually is the middle meningeal artery, especially the anterior division of middle meningeal artery at the region of Pterion. So usually it's middle meningeal artery or the anterior division of middle meningeal artery. Subdural hemorrhage is because of involvement of bridging veins, the veins which connect the dural venous sinuses. Bridging veins are usually involved in subdural hemorrhages. Subarachnoid hemorrhage is because of the rupture of Berry aneurysm. It is usually because of the rupture of Berry aneurysm, and the Berry aneurysm are usually seen in the anterior communicating and posterior communicating arteries. Rupture of Berry aneurysm, you will talk more about this in the medicine, that which part exactly. So it's anterior communicating close to the anterior cerebral and posterior communicating close to posterior cerebral, the arteries which are usually involved in Berry aneurysm. And intracerebral hemorrhage is usually because of the involvement of Charcot's artery, the Charcot's artery of cerebral hemorrhage, that is usually involved in the intracerebral hemorrhage. So guys, this is about the neuro part. I mean, the few things like basal ganglia and the diencephalon, that part is done in physiology because it's more about the connection. You hardly get a question on, and if you look at the question bank, There's no question asked in last 7-8 years on the basal ganglia and the diencephalon part. So the most important part in the neuroanatomy is the tracts, cerebellar peduncles, the white matter, and those ventral and the dorsal surface of the brainstem, where we there is all these peduncles, cerebellar peduncles and interpeduncular fossa. So when you do the question bank, you'll find that you probably will be able to do majority of the questions in one go only if you're done with this. I already gave you my mail ID and the Facebook link. I'm again writing it if you didn't get it that time, so that you can keep sending me your queries, your feedbacks. And Facebook page, as I said, the Facebook, I already got many requests which I already accepted, and the Facebook group, it's a closed group, that is anatomy. So it's a closed group you'll find over there. You go to that link, send in your request, you do it today only, so that you can get connected to my group and we can have a discussion on whatever topic you want to. So that is all for this time. We're done with the head and neck and the neuro part. When we'll meet next, the next discussion will start with the embryology. Again, a very important part, and a lot of questions are asked from them. So our next immediate discussion will be on the embryology. Till then, take care and have a good time.